These are the notes for section 9-7, and I have already gone through and filled out the vocabulary and filled in the diagrams, so I'm going to walk you through them, and then you need to pause as necessary to get that all written down. You should have your textbooks open to page 573. And we've been talking about different kinds of functions and things that we can use them for in the real world. And today we're going to talk about growth and decay, and we're also going to talk about interest for money. So an exponential growth is when an initial amount increases by the same percent over a given period of time. So what that might be is if you're talking about a population of maybe the coyotes in the area, and let's say that they're growing in population by a steady amount over 10 years. If you say they increase by 23% every year for 10 years, where will that get me if I already know the initial population? So this equation kind of sets you up to be able to do that. Now they tell you for exponential growth, you're going to use the equation y equals a times 1 plus r raised to the t power. Now those things stand for specific parts of your problem. Y is going to be the final amount. So if we were talking about that coyote population after 10 years, this would be a population. So it would be the number of coyotes in the area. A is the initial amount, so that would say the amount that we have right now. 1 will always be there, and R is that rate of change. So we said, I think I said 23% or something similar to that. That's where that 23% is. Now, they will common numbers, they will give you percent. You need to rewrite it as a decimal without the percent sign, so don't forget you're going to have to move the decimal place. And T stands for time in years. Okay? So let's go ahead and try one of these. We have the real world example on page 573 of the textbook, and that example reads, a radio station is sponsoring a contest. The prize begins at as a $100 gift card. Once a day, the disc jockey announces a name, and the person has 15 minutes to call. If they do not call within that amount of time, the prize will increase by 2.5%. So we have an initial amount, so let's find our pieces. We have A is our initial amount, and it starts out at $100. Okay? It increases by 2.5%, so our R is 2.5%. Now if I want to rewrite that as a decimal, I move it to the left 2 places. So that equals 0.025. And they're wanting us to set up a general equation. Now a general equation will not have a time because that's something that you would fill in specifically for the amount of time that you wanted. So if you look down, part B says, if no one calls in after 10 days, how much is it worth? So that would be T. But what if they said, okay, now find 15 or find 17? So we leave T in our general equation instead of putting in a specific number. So we start filling in, and we're going to say y equals 100 times 1 plus 0.025 raised to the t power. Now I can't do anything with that because I don't know what t is, but I can combine these like terms. So I'm going to say y equals 100 times 1.025 to the t power. And that's my equation for this word problem. Now they're saying, okay, I know that I want to know what happens after 10 days. So I plug in 10 for t. I'm going to say y equals 100 times 1.025 to the 10th power because I have 10 days. Okay? So I set up here that T is time in years, and that actually comes on the next page, and I'll show you what I'm talking about then. So we're just going to plug in 10 for right now. So I'm going to say 100 times 1.025 to the 10th power, and I get 128,008. So if I round, I get 128,001. So I have $128.01 for that gift card if no one has called on the 10th day. Turn to the next page. Now sometimes they're going to talk about something called compound interest, and generally what they're talking about is money. Compound interest is the interest earned or paid on both the initial investment and previously earned interest. So let's say we're talking about a loan. You take out a loan for college or for a car. The initial investment is how much you borrowed, and if they compound it, let's say they compound it every month, they're going to say, after a certain number of months, you've accrued a certain amount of interest. You owe that much more money because you have to pay somebody to borrow that money in the first place. And so it just kind of keeps building off of itself. So the interest is how much you have to pay in order to borrow that money. So A equals P times 1 plus R over N raised to the N times T power is our equation. Now our current amount is A, so how much you owe currently. P is how much you initially invested or lent out. 1 stays the same. R is still that percentage written as a decimal. N is the number of times it's compounded. So if I said it's compounded monthly and we had it for 1 year, we would put 12 here because there's 12 months in a year. These two N's will be the same number, and T is the time in years. Okay? So we're talking about the real-world example on page 574. It's example 2. Okay? And it reads, Maria's parents invested $14,000 at 6% per year compounded monthly. How much money will there be in the account after 10 years? So what they did is they put in some money and they're saying, okay, it's going to grow, so they're going to earn interest instead of owing interest. So let's start with our pieces. We are looking for A. We know that their principal or their original amount was $14,000. R, or the rate, was 6%. Now if I write that as a decimal, it's 0.06. N, they compound it monthly, so 12 times. And they say T, so the number of years, is 10 years. So we just take all of these little pieces and plug it into this equation. So we don't know A. We know that P is 14,000 times 1 plus 0.06 over 12 raised to the 12 times 10, because it's N times T, power. So I can start simplifying things. I'm going to say 14,000 times 1 plus, now on my calculator, 0.06 divided by 12 gives me 0.005 raised to the 120th power. I'm going to combine these and I'm going to say 14,000 times 1.005 to the 120th power. Now I'm going to take my calculator and I'm going to say 14,000 times 1.005 to the 120th power. And I get $471.55. So they put in $14,000, but 10 years later, they have a little over $25,000 in there. Turn to the next page. So on the first page we talked about exponential growth, where that coyote population was growing, but what if their disease hit them and they had their population shrinking and it was decaying? So use the same kind of equation to find those kind of populations. So exponential decay is when the initial amount decreases by the same percent over a given period of time. So it's the same thing as exponential growth, but it's talking about when things are going down. So we still have final amount, initial amount, rate, which is a percentage written as a decimal, and time. So we're going to talk about the real-world example on page 574. This is example 3, and it says a fully inflated child's raft for a pool loses 6.6% of its air every day. The raft originally contained 4,500 cubic inches of air. First thing we have to do is write an equation, and then they're saying after 7 days how much air is left in that raft. So we're going to start with our equation. We don't know y, that's what we're looking for. Our initial amount was 4,500 cubic inches of air times 1 minus, now our rate is 6.6%, but I want to write that as a decimal, so I'll move it 2 places, 0.066. And then we're saying, remember how we left t just as t because we want to write a general equation. So I'm going to go ahead and combine these. So I'm going to say 4,500 times, now 1 minus 0.066 gives me 0.934 to the t power. Okay? So that will be our general equation. Now they're saying, what happens after 7 days? Plug in 7 for t. So I get y equals 4,500 times 0.934 to the 7th power. Type that into our calculator. Okay, and we get 2,790.23, and then we're talking about cubic inches of air. Left in that raft after 7 days. So basically for this chapter, or for this section, you just have to take the given equations and plug in the necessary information. The easiest thing to do is to forget to change that percentage into a decimal, so make sure you're paying close attention to that. But that's the end of the 9-7 notes. Let me know if you have any questions.